All right, good morning, Chem 101 students, DE Chem, and Honors Chem students. Today is Wednesday, April 8th. Um, Many of you probably have already heard the announcement that starting after spring break, we are going to start grading again. So I want you to kind of know this. The first grade that I am going to take is going to be the Chapter 10 homework from Chem 101. Now, for those of you that are DE students, remember that Southeastern is grading all of the homeworks. So I'm going to leave the homeworks open up until the end of the term so that you can do as many of them as you can. You can go back through and finish up any of them that you haven't finished, things like that. That's going to be very important for your Southeastern grade. Remember that the drop date for Southeastern is not until May 26th, so you can actually finish the course completely, take the final exam, see what your grade is, and then if you decide you want to drop, you can fill out the paperwork, get it back to me and Miss Ward, and then drop the test. But it is going to take you actually doing the work, getting on here, watching the videos, things like that. All right, so a couple of things that I want you to out. I attached a problem called Lewis Structures Practice or Lewis Practice. I want you to open up that file. You do not have to print it out, but so you can do these on paper, so you're going to need to have some paper available. I also want you to open up the lecture notes that I attached with the videos, and I want you to find, so the lecture notes, page 1, starts off with this slide that it says Chapter 10 Bonding. All right, I want you to find in the lecture notes, I believe it's on page 11 or 12, I think it's page 12, I want you to find the How to Draw Lewis Structure notes. And I'm just going to go through and do some real quick notes on it. So step 1 talks about finding the middle element or the central element. They recommend looking up the lowest valence number. So we're going to pick the one with the fewest valence electrons. In this case, for sulfur dichloride, it actually works. A lot of times, you got to kind of reason it out. One of the notes that they say is note that hydrogen would be considered a high valence. Even though if we look at the valence numbers, hydrogen only has 1. Hydrogen is considered to be a high valence because it only can hold a maximum of 2 electrons. It's a duet. So just remember that. We're looking at the one that has the most electrons to fill it. All right. So, and then we'll use the subscripts to determine the number of atoms and things like that. So just to kind of go through here, remember that sulfur is below oxygen. Sulfur is going to have 6 valence electrons. So 1, 2, 3, 4, 5, 6. All right. Chlorine is a halogen. Chlorine is in column 7A. It's going to have 7 valence electrons. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. All right. Now, so when we're doing these, we also need to look at going through here. So they drew this for us, and they put them in here. And the reason why they put them in this shape, like an L, is because of how they showed that the single electrons for sulfur ended up on this side. So one ended up on the right-hand side, one ended up on the bottom, the way they drew it. All right. You really could have drawn this either way. We could have even drawn it with sulfur in the middle and a chlorine on each side. That's not, right now, that's not going to be the most important things. When we get into the computer programs and the applications, you're going to see some other things happen. All right. So kind of going through this and looking at this, I want to show us some practicality of this. All right. So it says finish drawing their electron dot structures for each one. So we put the electrons around it. I'm going to show you another method today called needed, available, shared. I like that method better, but either way actually works. All right. So in this one, we are circling the sets of unpaired electrons on the neighboring atoms. Um, so if you notice in this one, we have one unpaired electron on chlorine, one unpaired electron on this chlorine, and then two unpaired electrons on sulfur. So we make those. Now, what they're actually doing is they're showing that this is a covalent bond between those electrons. All right. So the end result, instead of showing the dots, we show a line to represent it. Now, that's the way Southeastern shows us. I'm going to show you a little bit different method just because I like this one better. And I also want to take us into doing it in the Chem 101 program. So, flip over to your Lewis practice. All right. I'm going to teach us a method called needed. And I'm going to do these in different colors, available, and then shared. What I like about this one is it helps whenever we have double and triple bonds that are going to be in it. And this is going to help us see some things happening. All right, it doesn't always work. It's not 100% perfect, but it is good. All right, so let's do D together. All right, so we have hydrogen cyanide, HCN. On this sheet, it actually kind of helps us out and it tells us which one is the central element. Now, again, so we're looking at the lowest valence number. So hydrogen has 1, carbon has 4, nitrogen has 5. The reason why carbon's in the center is we consider hydrogen to be a high valence because it only needs 1 extra electron. So when we talk about this needed, available, shared, the maximum number of electrons hydrogen can have, if it has a full outer shell, is going to be 2. Carbon has 4. Carbon will have 8 when it's full, and nitrogen will have 8 when it's full, because we're trying to get to that octet. So 8 plus 8 is 16, plus 2 gives us 18 electrons needed. That's 18 electrons needed to fill octets. Octets and duets. All right. Available, we're looking solely at the valence electrons. All right. So we're looking at valence electrons. So hydrogen has 1 valence, carbon has 4, and nitrogen has 5. Remember, those numbers are coming from the columns that they're in the periodic table. Just the easy way to remember valence electrons. So hydrogen's in column 1A, 1 electron. Carbon's in column 4A, 4 electrons. Nitrogen's in column 5A, 5 electrons. So 1 plus 4 is 5, 5 plus 5 is 10. So we have 10 electrons available. This is the most important number. This is the number we have to get to at the end. All right, so that means they're sharing 8 electrons. 18 minus 10 is 8. Now, when they're sharing, they're going to share in pairs. So 8 electrons as pairs, that means we're going to divide by 2, and so that gives us 4 bonds. All right, again, the reason why I divided by 2 is because they're sharing them, so we're looking at 2 electrons for a bond. All right, now, so let's go ahead and draw this and look at it as a drawing. All right, so I'm going to put carbon as my central element. And I'm going to put hydrogen on one side and nitrogen on the other. So remember, hydrogen can only hold a maximum of 2 electrons. So that's a single bond. Carbon needs 8 electrons around it. and nitrogen needs 8 electrons around it. So carbon is definitely going to make one bond, but to get 8 electrons, so I only have 4 electrons around carbon right now. So a double bond would be 6, triple bond would make it 8. All right, so right now I've accounted for 2, 4, 6, 8 electrons, and I need to get to 10. So where do I put those last 2? If I come back here, finally redraw the Lewis structure, replacing the circle sets of dots with lines connecting double. All right, this sheet really doesn't give us what to do with them. So if we have an extra set of electrons, we need to place those around the element that doesn't have a full octet. So now, nitrogen has 2, 4, 6, 8 electrons. Carbon has 2, 4, 6, 8 electrons. And hydrogen is full with this duet. Now, what I want us to do is I want you to open up Chem 101. And so like you're in this section here with your Chem 101, I want you to go ahead, find the little gear, click on that, and click on Free Draw. All right, so I want to show you how to draw this because there's a couple of homework problems that actually have to answer this problem in Chem 101, answer these type of problems in Chem 101. They didn't want you to draw these. So this is what you're going to be using to draw these. I'll show you what it looks like in the actual homework as well. So just kind of go from there. All right, so first things first is we need to make sure that we have 3 elements. So I'm going to come up here and I'm going to say that there's 2 bonds on that. All right, now to get the right elements, I don't want to just have the dots. I'm going to go ahead, click on my dot, or click on my center dot, and then I'm going to click on this little periodic table looking thing down here. And I said that carbon was my central element. I said, oops, let me go back. Carbon's my central element. I put nitrogen on this side, and it doesn't matter which side you put nitrogen and hydrogen on. You just need to make sure that they are on the outsides. All right, now the next thing is I have a single bond between hydrogen and carbon. I said there was a triple bond here, so I'm going to click on the bond. I'm going to slide my slider and put 3 bonds. Now, the last thing is that I said that nitrogen has a lone pair of electrons on the outside, so I need to add 2 electrons to nitrogen. Now, so I talked about each of these having 8 electrons. So let me show you something real quick. If you click on this little button that says valence electrons on here, it shows you that. All right, so notice that nitrogen has 8. We said that it needs 8. Carbon has 8, and then hydrogen has a duet with 2. So that's the basic how to draw a structure in Chem 101. Now, let me switch over to our homework and show you in here. All right. In Chem 101, I want you to go ahead and click on the Chapter 10, 10 problems. For day 1, I assigned you to do 1 through 5. Number 6 and number 6 you can skip. Number 7 you should be able to answer. Number 8 I want you to skip. I want you to go ahead and open up question 9. All right. I'm not going to submit this. I was playing around with this earlier just to show you some wrong ways and all of that. But I want you to go ahead and look at this one, number 9, and it says draw the Lewis structure of carbon dioxide. All right. So yours won't have anything in the model. So I'm going to go ahead and click reset. Now, again, when you're doing these, I recommend excuse me, I always recommend drawing these on paper before you do it in the program, because I want you to look at what's going on first. All right, so we have the compound CO2. All right, I'm going to use my method, needed, available, shared, for this. If each one of these had 8 electrons total, if it had a full octet, so we would have 8 times 3, which is 24. So we need 24 electrons. We're not ever going to get to that total number of 24. That's just if we lived in an ideal world and everything had an octet. All right. So what we need to actually look at is how many electrons do we have available. Carbon has 4, and each oxygen has 6. And there's 2 oxygens there. So we have 12 plus 4 is 16. 24 minus 16 gives us that there are 8 electrons shared. Now, if I'm sharing the electrons, I'm going to share them in pairs. So what that tells me is that I have 4 bonds total. All right. Now, so carbon is the element that's by itself, so I'm going to put carbon in the center. It's also the element with the lowest number of valence electrons. So I put an oxygen on either side. Now, I have 4 bonds. There's a couple of different ways that I can approach this. I could say that I have 1 bond here and 3 on that one, like our last one. Another way that I could approach it is I could say that it's double bond, and then a last way, which is basically the same as the first, it's just flipping the direction. I could say I have 3 on that side and 1 on that one. What I want to figure out is which one's going to be the best, which one's the most balanced. Well, if I'm looking at this one, I can, just looking at the pictures, this structure is going to be the most balanced. It's not complete yet. All right. Right now, we're saying that we have 16 available electrons. We're only accounting for 2, 4, 6, 8. Carbon has an octet, but we need to get an octet around each of the oxygen. So I have 4 electrons around this oxygen, so I need to add 4 more. So 2, 4, 6, 8. Same thing on this side, 2, 4, 6, 8. All right. And so that's 2, 4, 6, 8, 10, 12, 14, 16. So there's my number of 16. Like I said, the available is the most important number. All right. That's the number we have to get to. All right. Just to kind of finish this out, if I were to draw it this way, and I'm going to show you why this one is wrong in just a minute. But so we have 2 electrons here. We have 8 valence electrons around this carbon. We have 2 around this oxygen, so I need 4, 6, 8. And then I have 2, 4, 6. I need 8 around there. So again, this is still 16 electrons. 2, 4, 6, 8, 10, 12, 14, 16. Still 16 electrons, but why is one correct and the other one's not? So let's do it on the problem number 9 in here. So first thing, I need 3 elements, right? No, I need 3 elements, not 4 elements. All right, so I'm going to do this one. I'm going to set my central element as carbon, and then each of my side elements as oxygen. All right, now I'm going to show you this first example first, and then I'm going to show you why it's wrong. All right, so I want to put 6 electrons around that oxygen. I'm going to leave that there. I'm going to click on this bond type and I'm going to change it to a triple bond. And then I'm going to put 2 electrons around that oxygen. Now, again, if I click on my valence electrons on this, it's going to show me that I have 8, 8, and 8 electrons. That's fine and dandy. Everything works. But this other button I haven't showed you yet, formal charge, I want to click on that one. This button shows me that I have a -1 on this side and a 1 on this side and a 0 in the middle. We want to try to get these numbers as close to 0 as possible. All right, we're not looking at direction, we're looking at magnitude. So we want to get the smallest numbers possible. These 1s are concerning me. So I want to see if there's a better way that we can get to closer to 0. So I'm going to click on this oxygen, and I'm going to drop it down to 4 electrons. And I'm going to change this bond to a double bond. And I'm going to go over this one, change it to a double bond, and I'm going to give those 2 electrons that I just got rid of, I'm going to give on that side. Notice what happens to the formal charge. They're all zeros on this one. So that would be how you do it in the Chem 101 app. From there, you would click Done, and then you're going to click Submit. If the problem is right, it's going to tell you it's correct. If it's wrong, it's going to tell you it's wrong. I can guarantee you if you do it this way, I'm going to give you this one. This one's going to tell you it's correct. All right. It's more about getting you used to using the program than anything else. So what I would like for you to do now is go ahead, go back to the practice sheet. We're going to do one more problem together. And I'm going to kind of take you into this one so that you can see what's happening here. All right. Now, notice the difference between these problems at the top and these at the bottom. These have charges. They are ions. So when we do this, this -3 here is telling us that we are adding 3 electrons to the number. All right, where is that going to happen? That's going to happen in the needed. All right, so let's go ahead. I'm going to calculate the not the needed. It's going to happen at the available. Sorry, misspoke myself there. All right, I'm going to calculate the available first for this. All right, phosphorus is in column 5A, so it has 5. Oxygen is in column 6A, so each of these oxygens have 6, but there are 4 electrons, there are 4 oxygens there. So 5 plus 6 times 4 gives us 29 total electrons available. But remember, we have to add 3 more to that, so plus 3 gives us 32 available. All right, now for needed, every one of these can get a full octet of 8, so 8 times 5 is 40. And I don't know why I wrote 34. It's 32. So that means we are sharing 8 electrons. So again, if we assume that each of these is going to make a pair, so we divide that by 2, that gives us 4 bonds. All right, so drawing this, I'm going to put phosphorus in the middle, and I'm going to put an oxygen equally spaced around them. All right, I'm going to put 2, 4, 6, 8 electrons. So 32 minus 8 means that I need to account for 24 more electrons. And so phosphorus has an octet with 8. And then if I put 6 electrons around this oxygen, that's going to give me 8. 6 times 4 is 24, so that accounts for the rest of the electrons. You can always double check at the end to make sure you have a total of 32. So again, 6 times 4 is 24, and then 26, 28, 30, 32. And there's your drawing for that. Now, because this is a -3 charge, we need to account for that -3. So in the program, I believe if you have to do one of these in Chem 101, you're going to click on this central element and tell it that it has a charge of -3. If you were drawing one of these on your own, if you're drawing it on paper, the way that we show this on paper is we're going to put brackets around it and put a -3 charge on the outside. All that's doing is telling us is that we have 3 extra electrons. Now, go back to Chem 101 again. And I want to look at one more problem. I'm not going to do this one, but I'm going to show you how to get started on it. All right. So problem number 10 says the Lewis structure for ammonia, NH3, is shown below is incorrect. Starting with this structure, complete the correct structure. The way I would approach this problem is when I click on the module, I'm actually going to just reset the whole thing, and I'm going to start from scratch. I'm going to pick one that's going to be my central element, and I'm going to call that central element nitrogen. And I know that nitrogen is going to be bonded to 3 different things. And then from there, you can start actually working the problem. What I'll tell you to do is, again, do this on paper first before you do that. And the other thing to notice is know that NH3 and NH4 plus are 2 different things. So this structure is not going to be this structure. They're going to look completely different. All right. So do your needed available shared, things like that for it, and go from there.